Salam alaikum wa rahmatullahi ta'ala wa barakatuh. Welcome back to my channel, everyone. And if it's the first time that you're on my channel, welcome to this video. So today we're going to be doing episode 13 of applying product rule to trigonometric function. And as you can see, the 13th question in this series is secant x multiplied by cosecant x. So the first thing you have to do is, first of all, understand the type of rule you're supposed to apply to this question. In this particular question, we have two subfunctions, secant x and cosecant x, and these two subfunctions are multiplied by each other, and we're asked to take the derivative of this function. So whenever you have two subfunctions multiplied by each other and you're asked to take the derivative, you're going to apply something called the product rule. Product rule is the derivative of the first subfunction multiplied by the second subfunction plus the derivative of the second subfunction multiplied by the first subfunction. So now that we have that information down, we're going to compare our question to the general information position. So in this case, we have f of x here equals to secant x. As you can see, f of x is going to be the first subfunction in the full function, and in this case f of x, and then g of x is the second subfunction in the full function, which is cosecant x. So now that we have all of this information down, we can go on to differentiate. So the derivative of secant x multiplied by cosecant x equals the derivative of secant x, right, multiplied by cosecant x plus the derivative of cosecant x, okay, multiplied by secant x, which is obviously f of x. So now that we have this information, we can proceed to differentiating it. But one thing you need to know is anytime you're given a question that involves trig, you should be able to know how to use trig properly by studying trig notes, trig functions, and basically learn the formulas in trig, whether it's trig expression, trig identities, and derivatives of trig. So in this video and in all my other videos in this series, as well as all my videos that relate to trigonometric functions, such as solving trigonometric functions using quotient rule or applying chain rule to trigonometric functions, those series always have this page, and this page is dedicated to trig notes. So on the left side of the page, where majority of the stuff are written in blue, this is called trig expressions. Okay, trig expressions are basically how one trigonometric function relates to another trigonometric function. That's what trig expression does. Like, how does sine x relate to another trigonometric function? In this case, sine x is equal to 1 over cosecant x, and cosecant x is the same thing as the reciprocal of sine x, or tan x is the same thing as sine x over cosine x, or cotangent x is the same thing as cosine x over sine x. So basically, it's how trig functions relate to one another. That's what trig expression is. Then you've got trig identities. Trig identities are commonly seen basically whenever you have trig information having squares. So as you can see, sine square x plus cosine square x equals 1. Cotangent square x plus 1 equals cosecant square x. Tangent square 1. Tangent square x plus 1 actually is equals to secant square x. And you can see that all of these have squares, and those are trigonometric identities. Now, for everything that is written in black, like at the bottom of the page, the bottom right as well as the very bottom left, is what you would call trig derivatives. So here we have all the derivatives of trig. So if this is the first time you are watching my videos, please pause this right now and copy down all of this information in the trig notes. For students who have consistently watched my channel and watched this series, they already know what this information is and what it basically entails. So, but if this is the first time, just take a break and just copy it down because it will help you for the rest of this series, as well as the series on chain rule and quotient rule and any other videos or any other learning resources that involves trigonometric functions. So now that you know that, what is the derivative of secant x? Well, here we have the derivative of secant x, and the derivative of secant x is secant x tan x. So we're going to write that down. So here we have secant x tan x. Then you have cosecant x not doing anything, just chilling. So we're just going to bring it down and multiply and say cosecant x. Plus, what is the derivative of cosecant x? Well, when we go to the previous page, the derivative of cosecant here is negative cosecant x cotangent x, cosecant x. So here is equals to negative cosecant x cotangent x. So we have negative cosecant x cotangent x, right, multiplied by secant x. So now you have all of this information, and basically the answer is going to be secant x tan x, right, cosecant x minus cosecant x minus cosecant x cotangent x secant x. So this is basically the answer. So when you apply the product rule to secant x cosecant x, this is literally your answer. But guess what? Because we're dealing with trig, like, you can't just put this answer. I mean, this answer is 100% correct. What you just did is 100% correct. But whenever you're doing trig, it's best for you to simplify, just because you have an entire page of notes that have trig expression, trig identities, and basically trig derivatives, and you can play with the answer. In this particular case, we're going to use trig expressions to break down this information so that we have a simplified and more compact answer. And we do that because everything in mathematics that can be easily simplified, and even if it's difficult to simplify, we love to simplify. That's really it. So I'm going to copy this information on the next page, and we're going to simplify it. So we have this, from the previous page, we have secant x, right, tan x cosecant x minus secant x cosecant x cotangent x. So from this information, obviously this is a full one. What is the thing that we can do? Whenever you try to break down information in trig, I'm going to advise you to stick to doing sine and cosine. So at least personally, what I like to do is to take all of this information and try to break them down into sine and cosine, because sine and cosine are the simplest and easiest to remember of the trigonometric functions, right? So we break down all of this information to with sine, and then we see what we can do to simplify further. So you have secant x. What is secant x? If we go back to our trig notes, secant x is the same thing as 1 over cosine. So we have 1 over cosine of x, and then you have tangent. What is tan x again? Tan x is 1 over cotangent x. But then I said the best way for you to simplify trig information is to just put everything in terms of sine and cosine. Tan x is also equal to sine over cosine. So I'm going to put here sine x over cosine of x, and then you have here cosecant x. What does cosecant x represent? Cosecant x, when you look at trig notes and you look for what cosecant x represents in terms of sine and cosine, you see that cosecant x is the same thing as 1 over sine x. So we go put it down there. So that's 1 over sine x, right? Minus, we have secant x. What did we say secant x was again? Same thing as 1 over cosine of x, right? And then what did we say cosecant x was again? We said that's 1 over sine of x. Then what is cotangent x? Well, when we go to our page, our trig notes page, we have cotangent to be 1 over tangent. But guess what? We were trying to get everything in terms of sine and cosine because it's the easiest way for us to find what would be helpful for us to simplify, right? So cotangent is equals to cosine over sine. So we're gonna put cosine x over sine x, right? So now that we have this information, what do we do next? What we're going to do next is for us to have our usual in math. Whenever you see two things that can cancel out, you try to cancel them out. That's really what it is. So we're going to cancel sine x here, sine x here. We're going to cancel cosine x here and cosine x here. And I'm going to rewrite what we have. So we have 1 over cosine times cosine, so the denominator. Cosine times cosine, what does that represent? That's going to be cosine squared of x, right? Minus 1 over, we've got what? We've got sine and sine. So that'll be 1 over sine squared of x. So this is basically our answer. But that's the thing though. In order for us to make our work neater, it's important for you to know that this answer is correct as you apply product to this first answer that we got when we first applied the derivative on secant x multiplied by cosecant x. This answer is correct. It's just a rewrite of what we had in the previous page. This answer is also correct. But the only reason why these two answers are different is because we simplified this answer further and then we got that to be this answer. But our work is not done. In order for us to make our work neater, just my personal preference, what does 1 over cosine square x stand for? When we look at our trig notes, we have cosine, we have 1 over cosine here, right? But 1 over cosine x is the same thing as secant x. But then what does 1 over cosine square x represent? Is the same thing as saying 1 over cosine x and another 1 over cosine x. So that's the same thing as saying same thing as saying secant x multiplied by secant x. And what was that going to give you? You're going to get secant square x. So 1 over cosine square x is the same thing as secant square x. So yeah, we don't need to overthink it. That's really what it is. So we have secant squared of x and then minus 1 over sine square x. What does that represent? 1 over sine square x. When we go to our page here, we know that 1 over sine is the same thing as cosecant, right? 1 over sine is cosecant. But when we have 1 over sine squared x, we can just write that to be cosecant squared of x. So this is basically the answer. Like I said, this answer that we got when we applied the product rule that is complicated is okay. This answer here is okay, and this answer is okay. But I choose to leave my answer in the third way, which is just what I just showed you now, because it's the neatest. Imagine if I was to remember, or I was to write down my answer to be secant x tan x cosecant x minus secant x multiplied by cosecant x multiplied by, that's a lot of information. Or I could just simply say secant square x minus cosecant square x, and yeah, easier to remember, easier to say, easier to solve for, like, to be honest, because you could have this instead in a multiple choice question, and then, but this is what you solve. But if you don't have understanding of the trig expression and how to play with trig, you're going to be stuck. But I'm happy this video teaches you to be unstuck, right? So that's it. And many of you guys know that I like to make shortcuts to all of this video. This one unfortunately doesn't really have a shortcut. The shortcut is actually a process which will still involve some level of mathematics. So I'll just advise you to learn the trig. I'll just advise you to learn the product rule and understand it based on what you've been watching so far in the series. But if you were to do a shortcut, this is what you would get. you have secant x, right? And you have cosecant x, and you were to do a shortcut and you were supposed to derive them. Well, the first thing that we do whenever we do shortcuts is to just write the functions by themselves and see if the functions can be simplified before we go on to differentiate it, right? That's what we do. So in this case, secant x is the same thing as 1 over cosine of x, and then that's multiplied by 1 over sine of x. So what you eventually have is 1 over cosine x sine x, and then you'll be asked to do the derivative of this information here. Take derivative. But guess what? This is not the easiest thing, and it's not necessarily the easiest thing to derive. So unfortunately, there is no shortcut method for this, because in order for us to simplify it, or the process of simplifying it makes it a little bit more complicated. But I believe, like, if you want to apply quotient rule to this, you can go ahead and do it. You're gonna get the same answer we got here, which is secant square x minus. You can go ahead and apply the quotient rule, but the truth is you're just gonna get the same answer here, secant square x minus cosecant square x. So that's why I still prefer the regular method rather than the shortcut method in comparison to the other videos that we've done so far, where we could find out the answer in a quicker way. So I hope this video has been very helpful to you guys, and I hope you guys have learned something from it. I know I did. I wish you guys all the very best in your exam, in your schoolwork, and in your journey towards learning calculus with me, and hopefully with other external resources as well. Make sure you take very good care of yourself. Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh.